Hi, here I am going to go through the heart model with you like I had hoped at the end of class. I'm going to assume that you know the pericardium pretty well, the fibrous pericardium, parietal pericardium, and visceral pericardium. The visceral pericardium, when we're talking about the heart, is called the epicardium. So the epicardium is the outermost layer of the heart. The inner muscular layer is the myocardium, and the innermost layer is the endocardium. When we're looking at the heart, we need to get our external landmarks. So here's the apex, the point of the heart. Here's the base where the great vessels come out. We have the atrioventricular groove. So here's the atria, here are the ventricles, and the groove between them is the atrioventricular groove. We can also call that an atrioventricular sulcus. Here we have the interventricular groove or sulcus that divides the right and left ventricles. Again, we have two superior chambers, two atria and two ventricles. Here's the right atria and the left atria, the right ventricle and the left ventricle. Between those chambers, right here and right here, are the septa. There's the interatrial septum, which is the wall between the atria, and the interventricular septum, which is the wall between the ventricles. We have two types of valves on each side. We have semilunar valves, which are the valves between the ventricles and the vessels. And we have atrioventricular valves, which are the valves between the atria and the ventricles. So on the right side, we have the tricuspid AV valve. On the left side, we have the bicuspid AV valve. And here, going into the pulmonary trunk, is the pulmonary semilunar valve. And much harder to see there, actually, this camera really helps. And the aortic semilunar valve is right there. The atrioventricular valves are anchored by these cords called the chordae tendineae, and the chordae tendineae attach to papillary muscles. And the reason why we have these is because as blood fills the ventricle down here, pressure eventually is going to increase down here, much as the back pressure is going to increase here, so it's higher than the atria. And what would normally happen if this wasn't anchored is that the flaps would go back, they'd like reverse into the atria. But because these chordae tendineae anchor the valve, the flaps are just going to close instead of inverting. Okay, so those are our valves. We're going to talk about our great vessels. So I told you to anchor yourself, find the auricles of the atria. The auricles are these little flaps that actually act to increase the volume of the atria if necessary. So here are the auricles, and between the auricles is the pulmonary trunk. It's the most anterior vessel. Next we have the aorta, and then behind the aorta is the superior vena cava and the inferior vena cava. And so superior and inferior vena cava feed the right atrium, goes down through the tricuspid valve into the right ventricle, up through the pulmonary semilunar valve, into the pulmonary trunk, through the pulmonary arteries to the lungs. From the lungs, it's going to return through pairs of pulmonary veins to the left side. Left side, it's going to go through the bicuspid valve into the left ventricle and up through the aortic semilunar valve into the aorta and to the systemic circuit, all the organs and tissues of our bodies. Okay. And I think I may have hit them all. Okay, so just very quickly, epicardium, myocardium, endocardium, atrioventricular sulcus, interventricular sulcus, left and right atria, left and right ventricles, divided by the interatrial septa and the interventricular septa. We have the tricuspid and bicuspid valves. So you tri before you bi. And then we have the pulmonary semilunar valve and the aortic semilunar valve. Okay, so that's a nice little tour of the heart. I hope this is helpful. I will have captioning on it within 24 hours, so I'm going to post it now so you can start studying, but the captioning will be there shortly. Thank you. Bye.